So today we are looking at slope from a table of values. So you're going to have these little tables with x's and y's on them, and we are going to find the slope from those tables. Which finding the slope isn't the hard part. The hard part is figuring out whether or not that table even makes a line. So yesterday I gave you a graph, and it was very obvious that there was a straight line on it because you could see it. Today, we're going to be looking at whether or not relationships in these tables are even linear in the first place. So a linear relationship has a consistent rate of change or slope. Your slope, we learned yesterday, is rise over run. So I'm going to put run right. And if we remember yesterday, I spelled rise wrong with a Y. It's because another way you can think of your slope is the change in your Y values space there, over the change in our X values. So how much are your Y values changing? Divided by how much are your X values changing? Logan, Dorian, take notes with us, please. Okay, so we are going to find the change in our Y values. We're going to find the change in our X values. The first thing that we are going to do is ensure that they are consistent. If those are not consistent, then we are able to just circle down here on each problem. I have a spot that says nonlinear. We're able to circle that it's not linear. If it is not linear, meaning it doesn't make a line, we can't find a slope. If something's not a straight line, it doesn't have a slope. If it is consistent, then we will circle that it is linear and we will find the slope. Okay? So if you circle nonlinear, you don't have to find a slope because there is no slope. So starting out with our first one, we are going to be looking at the change in our Y values. So I'm always going to start with the change in my Y values. So I need to look, let me get a different color. From 5 to 3, how much do I go up or down? 2. I'm going down. So I'm going to write down -2. You're going to want to write these down to keep track of them. So we're going to be able to compare them. From 3 to 1, I'm going down 2, because 3 minus 1, or 3 minus 2 is 1. Sorry. And then this one's a little tricky when you cross over the 0. 1 to -1 is also down 2. So far, the change in my Y values has been consistent. Okay. Then from there, we need to now look at the change in our X values. So the change in our X values, we go from -1 to 0. What do I have to do to go from -1 to 0? Add 1 or go up 1, so plus 1. From 0 to 1, I also go up 1. And from 1 to 2, I also go up 1. Okay. These are our nicest examples because this is a linear relationship. I can tell because my change in Y's and my changes in X's are consistent the entire time down. And then my slope, this is the tricky part, you got to flip it, is change in Y over change in X, so it's -2 over 1. Okay. Any questions on that first one? In that case, we will move on to our next one. So we're going to start with our change in y's. So for our y's, we go from 2 to 3. So to get from 2 to 3, we have to add 1. 2 plus 1 is 3. And then we go from 3 to 5. To get from 3 to 5, we have to add 2. And then to get from 5 to 9, we have to add 4. Okay. You cannot determine right now whether this is linear or not, because we need to compare this to the change in our x's. Because depending on what the change in our y's are, even if they're not all the same, there's sometimes where they're still linear if the x's also aren't like the same change. I'll show you how to do that on the next one. So now that we go to our x's, we go from -1 to 0, 0 to 1, 1 to 2. That's the exact same x's as right here. So it's the exact same. We add 1 every time. Add 1, add 1, add 1. Okay, so what we have to do now is we have to look and see if these slopes are the same. So the slope between here and here would be 1 over 1, 2 over 1, and 4 over 1. So we have to compare those. 1 over 1, 2 over 1, 4 over 1. Are those slopes the same? Is going up 2 over 1 the same as going up 4 over 1? So are they the same? Yes or no? Are they the exact same numbers? No. And they're not the same values either. So they're not. So there's going to be times where they're the same numbers, but they're the same values. These can't be reduced into the same values. So these do not equal each other. This one is non-linear. So you circle non-linear, and then you don't have a slope. You can just cross out that box. Okay. We've got a couple more tables, and then we have some tables with graphs on the back. So the next table, we've got 1, 3, 5, 9. So we're going to look at these, see what the change in our y values are. So to get from 1 to 3, I add 2. To get from 3 to 5, I add 2. And then to get from 5 to 9, how much do I have to add? 4. Thank you, Ariana. Plus 4. Okay. So looking at our x's now, to get from -5 to 0, I have to add 5. To get from 0 to 5, I also need to add 5. And then to get from 5 to 15, how much do I add? 10. Okay. So this one, my changes aren't the same, but I need to compare them and see if they mean the same thing. So I've got 2 over 5, 2 over 5. I know those are the same as each other because they're the same. So I'm going to write down 2 over 5. And then this one is 4 over 10. Are 2 over 5 and 4 over 10 the same thing? So they don't look the same. What could we do with 4 over 10? Is there anything we can divide 4 and 10 both by? 2. So if we divide 4 by 2, we're going to get 2. If we divide 10 by 2, we're going to get 5. So 4 out of 10 would reduce to the same thing as 2 out of 5, which means these ones are equal, and this is linear. If you don't want to spend time reducing fractions, you can use the calculator to check to see if they're equal to the same thing. Since fractions are just division, you could throw in your calculator 2 divided by 5, get 0.4, 4 divided by 10, get 0.4, and know that those two are equal to each other. Okay? So that means our slope on this one, we want our reduced version. So our slope here is 2 over 5. So those ones are linear, and our slope is 2 over 5. Okay, last one. We've got 7653. So that's counting down 7. So I go down 1. 6 to 5, I go down 1. But then 5 to 3, I go down 2. And then 1, 2, 3, 4. Those all just go up 1. Up 1, up 1, up 1. Okay, so from there, I now need to compare the two different slopes that I have at different levels. So negative 1 over 1 and negative 1 over 1, I know those are going to be the same. So I'm going to write that down one time. The other one is negative 2 over 1. These, neither of them can be reduced, so these are not equal. So this one is nonlinear. Hey, go ahead and flip this over. We've got a couple on the back where we are going to do graphs. I think it's going to be good for us to visualize what it looks for something to be nonlinear. So on the back, and on the back of your assignment too, we have some where you guys are going to put graphs. For your graphs, these are all of your x's, these are all of your y's. So these are all ordered pairs x comma y. They're just organized in a table instead of being organized as ordered pairs. So negative 3, 1 means we'll start at 0, 0. We'll go left 3, up 1. Zero, 3 means we'll go over 0, up 3. 2, 6 means we'll go right 2, up 6. And then 5, 7 means we will go right 5, up 7. Okay, is this a straight line? No. If I try to grab my ruler and lay it down, that guy is not as part of my line. So it doesn't mean I did something wrong. It means that this is not a linear relationship. It's nonlinear. If they made a straight line, I would just connect them, and then I would find the slope. Okay, last one. 1, negative 2. So I go right 1, down 2. 1, 0. So I go right 1, up 0. 1, 2. I go right 1 up 2. And 1 4. Woo. Right 1 up 4. Do these guys make a straight line?
Yes.
Yeah. So if I'm able to lay a ruler down and connect them, then yes, they are linear. Okay. This is one of our special slopes. Anybody remember what the slope of a line that looks like this is? It's not the 0. Somebody said it. Somebody said it really quietly, but you were right. Undefined. Yes. So I'm just going to write UND. I'm not writing out that whole word. Hey, any questions right now? Okay, I'm going to go ahead and stop this recording then. Bye, recording.